Now we're going to do the u substitution idea, but do it for definite integrals. So we have bounds here. So remember, these bounds here match up with this variable integration. So these are going to be your x bounds. So in order to integrate this, we are going to have to change it to our u bounds. So I'm going to go ahead and take the antiderivative first like we normally would. So notice that my u is x cubed plus 8. The derivative of that would be 3x squared dx. So notice that I'm missing a 3 here. So this is my du, and then all of this becomes my u, but I do need a 1/3 to keep it balanced. So this, we're going to do the rewrite as 1/3 u squared du. Now, since we changed this all terms of u, we also need to change the bounds. So these numbers are your x bounds. So this is really x equals 1. So to figure out the corresponding u bound, we're going to use this substitution. So when x equals 1, if I plug in 1 for x here, 1 cubed plus 8 gives me 9. So I'm going to replace this with the 9. And then when x is negative 2, which is the lower bound, when I plug in negative 2 here, you get 0, so that's the lower bound. So the idea is now when you take the antiderivative, you get 1/3 u to the third over 3, and you can plug in these bounds in for u to find the correct numerical value, which is 81 here. Okay. So step 1 is to take the antiderivative like we've been doing before. So remember we talked about typically when you have powers on the bottom, not raised to the first, let's bring it to the top. So I'm going to do this. My u in this problem is x squared plus 1. My du is 2x dx. So that's why that extra x is there. So if I do the rewrite, this is really u to the negative 3. Everything else in the problem should be du, which it is, except I'm missing a 2. So if I put a 2 there, that becomes du, but that really means I need a 1/2 in the front. So this is going to be rewritten as 1/2 u to the negative 3 du. So I'm going to take the antiderivative. Oh, let's do our bounds. So my bounds are 0 and 2. So let's start with the lower bound. When I plug in x equals 0 into here for x, my u becomes 1. And the upper bound is x equals 2. When I plug in 2 into the for x squared there plus 1, my u bound is 5. So these are the new bounds I'm going to use here. So when x is 0, that was the lower bound. So from 1 to 5. So it's going to be 1/2, add 1, divide by the power. And I'm going to clean this up a little bit before I plug in the bounds. So the u squared drops here. And I'm going to go here. So negative 1/4. I'm going to pull that out. So I have 1 over 25 minus 1. Whatever this value is, that's our answer. Okay. Next one. There is an antiderivative for secant squared, so that my u has to be the angle, which is 4x. My du is 4 dx. Notice I need a 4. So really I have secant squared u. I need a 4. This will be du. But then I need a 1/4 here. So this gets rewritten as 1/4 secant squared u du. Again, these are my x bounds, so I need to change them. So when x is pi over 24, I'm going to plug it in here. 4 times pi over 24 is pi 6. So my u is pi 6. And then plug in pi over 16. When I plug in pi over 16 here, I get pi over 4. So this is my lower bound, because that pi over 24 was in the bottom. This is my upper bound. So I can take the antiderivative. Antiderivative of secant squared is tangent. There's my new bounds. And I get 1/4. Tangent of pi 4 is 1. Tangent of pi 6 is root 3 over 3. Last one here, my u is 4 minus x squared. My du is negative 2x dx. That's why you see that extra x there. Again, anytime I see numbers in the front, I typically pull it out. So I'm going to pull that negative 8 in the front and rewrite it like this. So notice I have u to the 1/2. Everything else has to be du. So notice I do have a du. That's why that extra x is there. But I need a negative 2. But if I multiply by negative 2, I need to divide by it. So notice the number in the front really becomes a 4 when I do the rewrite. And then I have u to the 1/2 du. My bounds, when x is 0, I'm going to plug it in here. Your u ends up being 4. And then when x is 2, your u ends up being 0. Make sure you put these numbers in the correct place. It doesn't always have to be smaller number on the bottom. When x was 0, which was the lower bound, u is 4. So the 4 goes here, and the 0 actually goes here. So the antiderivative is add 1, divide by the power, and there are my bounds. I'm going to clean this up a little bit. So it's 8/3 u to the 3/2 from 4 to 0. So if I plug in 0, 0 to the 3/2 is still 0. If I plug in a 4, you get 4 to the 3/2. I'm going to simplify one more step. Remember, this is really the square root of 4. That's the 2 on the bottom, which is 2, and 2 cubed.